Bosch camera cybersecurity. Cyber's a big deal. I'm going to introduce a gentleman who is a genius. He really is. But there was a Target breach in 2013 at Target. I don't know if anybody recalls that, but my wife is a big Target shopper. I'm from Rehoboth Beach, Delaware, and we call it Target. It cost Target $202 million because 40 million credit and debit card holders were breached. So aside from the $202 million, as a consumer, it placed doubt in my wife's mind. She said to me, should I go to Target? Can I use my credit card? So think about all the people that walked in and out of Target. So is cyber a big deal? Yeah, I think it is. David Brent is the Senior Cyber Data Security Technical Instructor at Bosch. If this guy is not smart, I don't know who is. He's going to be talking about cybersecurity features at Bosch. So let's give it up for David from Bosch.
Thank you, sir. All right, so wow, there's real people here. This is amazing. I haven't seen real people in like almost 2 years. This is crazy. How you guys doing this morning? Hoorah. First session, we're going to take it nice and easy, and we're going to talk about what is actually going on with our cameras and our company. So it sort of gives you an overview of what to expect when you get one of these cameras off the table. Who are my technicians in the room? Okay, there's my techs. Who are my data geeks? I got a shaky hand. I got one confidence. Who are just like really cool people that just like showed up to have a good time? Okay, cool. So what we're going to do is the first thing, and I'm not a sales guy, we're going to talk about the cameras and the base features that you get with the cameras and some of the little things that you might not know about with every Bosch product that you get. We're going to talk about the cameras. We're going to talk a little bit about software. Second session, we're going to dive a little bit deeper into why everybody in this room is in deep doo-doo. Okay, we're going to talk about brute forcing. We're going to talk about social engineering. We're going to talk about lateral movement from your camera system if you have an older product, or how an attack vector is actually specified, and how the bad guys actually go about getting into your system. Because I know a lot of people in here are like, man, I'm in a government facility. You can't get to my cameras. You can't do anything. This is a waste of time. I'm sorry. Do you have anybody in your actual facility named Billy Bob the Tech that walks around with a nice little shirt that's got a tag on it? Chances are you've got a vulnerability that walks in and out every day. So we're going to talk about that. Right off the top of the bat, though, the first thing I want to talk about is the fact everybody in here knows Steve Pennington, right? When I got out of the Marine Corps and I started working for a company out of Denver, the very first CCTV class I taught, guess who was sitting in the class with me? Steve Pennington. That was my rude awakening from teaching a Marine Corps class and having everyone pay strict attention to what I said, to every other word saying, but you boy. So me and Steve go back a long way, 2001. One of the reasons I left that company in Colorado and I came to Bosch, Steve called me up one day and he said, dude, he goes, I'm getting ready to flip to this company and you got to talk to these guys in Germany about their product. And when I was talking to Marcus and Dieter, being from the IT field, the first thing I asked was, what's the deal with how you guys are treating the cameras from a security perspective? And the first thing out of Dieter and Marcus's mouth was, so what we did is we bought this company called VCS. And VCS was actually a startup company in like 1995. And what the conversation evolved, and they said, you know, we had the option of buying SmartSight, Axis, or VCS. And I said, why'd you do it? And they said, well, here's the deal. Part of the bill of materials of the encoders way back then, we had a thing called a crypto coprocessor. That is a hardened chipset that contained certificates. So way back in 2004, 2005, we were able to do 802.1x communications on a closed network. And I was like, wow, that's insane. I can't get guys in my class to say IP because they're all camera hangers. And you guys actually have devices that will do secure communications. This is fantastic. And then as we got on into it a little bit more, they were like, by the way, we also have a closed operating system. It's a proprietary operating system developed by the guys at Bosch, and it's closed. You can't write anything to it. You can't get a third-party app on it. So I was like, this is really cool. So way back in 2004, we had our fingers in the cyber pie, so to speak. Now, during these 2 sessions, I'm going to pimp my cybersecurity class. Who in here has sat my cybersecurity class? Oh my gosh, I have victims, don't I? So the people who haven't sat my cybersecurity class, and we've gone virtual. 2 weeks after the pandemic, I rolled out a solution so that we could do all our virtual training. We do BVMS, IVA training, camera fundamentals, cybersecurity. If you have not registered, I've got a cybersecurity class coming in a couple weeks, and I've got empty seats. Talk to these young gentlemen how they like the class, and possibly we can get you registered, because educate, and he's back there shaking his head. I'm not going up there. Okay, so here's the deal. Why is it really important what we do? The first thing I want to talk about is the fact that we use a secure engineering process. So anytime that we're producing a product, a camera, a piece of software. I'm going to pick this guy up because it's the only stage prop I got. Every camera that we produce, we use what is called a secure engineering process. Okay? That means before we put software to chipset and all that good stuff, everything is locked down, and we make sure that from a blueprint standpoint, it is as secure as it's going to be when it goes out the door. Make sense? Now we got this other thing. We do pen testing, and I get this question a lot. Well, do you guys do internal pen testing or you do external pen testing? We do internal and external pen testing. We have third-party partners. One of our software partners is a company called Vdoo out of Israel that it started up by the guy who used to run cybersecurity for the Mossad. Our hardware testing is done by Cure 53 in Germany. And we have a couple of other third-party partners that actually do extensive pen testing besides what we do. Now, one of the things that we're going to talk about is we're going to talk about OWASP, and that is Open Web Application Security Process Protocol. I can't remember what the P stands for, but that is one of the little things that people miss. So when you come to my cybersecurity class, I teach you guys how to do a basic vulnerability scan. We use Rapid7 if you're in class. We'll use Nessus by Tenable if we're doing virtual, and that's based on what I can do from a license standpoint. And one of the things that you don't pick up with a standard vulnerability scanner is it doesn't go really in depth to what the web page presents as an actual issue. Okay. Now in our second session today, we're going to talk about all kinds of things like cross-site scripting and injection and stuff like that. And we're going to kind of give you a peek behind the curtain, because we've been in the industry a long time and doing stuff for a really long time, and it's finally, other companies are starting to try to actually say, wow, we can't get away with just giving people crap anymore, because people are actually concerned about their security. But there's some companies out there that are doing a little sleight of hand. I'm going to show you how this sleight of hand is actually working. And we're going to do that by using a couple of OWASP tools like OWASP Zap. Okay. Now, before we put a product out, we do OWASP testing. We do mobile security project testing. We also adhere to NIST 800, CIS, and STIG testing. So that way, when you come, you get the product and your IT guy goes, man, we got to do a vulnerability scan and a pen test on this. You can pretty much guarantee that, guess what? It's already been done, and you're not going to get sideswiped. Make sense? Now, one of the things that, and I'm going to say this is probably the best kept secret at Bosch. Everybody knows what a CVE is, right? Because when the doo-doo hits the fan, it's like, oh my gosh, they got a CVE, and it's got a CVSS score of like a 9.8. You know, everybody's freaking out. I mean, we've all seen it, right? The cool part about this, and I didn't know this, like until 4 years ago when we started doing a cybersecurity class, Robert Bosch is actually a certified numbering authority for MITRE.org. Now that means, because we have a PCERT team, that is a Product Security Incident Response team, that if we have anything that is found by our pen testing partners, our internal testing, anything like that, and based on the actual CVSS score that the issue has, they have a certain amount of time to actually turn around and say, we are developing a fix, it'll be out in this amount of time, this is how we're going to deal with it, this is how we're going to inform our customers. But being a certified numbering authority for MITRE.org means that we don't have to wait for a third party to produce a CVE for us. We actually produce our own CVEs and we publish them through MITRE.org. So we have a faster turnaround time. Now I'm going to say straight up, in the time I've been with Bosch since 2005, we had one CVE in December of 2018 that got a 2-week turnaround time. And that was because we had produced a new feature for a European banking firm, and there was a little slight wrong way the memory handled the web page, and we had an issue. We got a turnaround time in 2 weeks, okay? So from the camera side, we've been pretty thorough about actually knocking this stuff down. Now, I said earlier we have a closed OS. In just a little while, we are going to talk about CPP 13, which is our new common product platform, and it's our Antiox cameras. And then we're going to talk about CPP 14 and beyond. Now, we have a closed OS and we have a closed ecosystem on the CPP 13. We're going to talk about how it's slightly different. And there's going to be like our whole entire product line. We got a little bump in the road, which is CPP 13, because it's a different product with a different attack, what you want it to do. And then we're back to normal with 14 and above, okay? Now, with that being said, a couple of things that most people don't understand, and this is massively important. Does anybody know what a downgrade attack is? Put your hands in the air, wave them around like you just don't care. Do you know what a downgrade attack is? I'm looking. Okay, we'll talk to you. Nobody knows what it is.
I think it's when a hardware device doesn't upgrade to the next like the next patch.
You are so almost not close. Yes. I'm just busting on you.
Is that when you change the firmware on a device to be able to a lower grade than what
Yes.
so that you can implement an already previously established attack vector?
Exactly. Yes, sir. All right. So downgrade attack is, if I got camera B here, right, and I'll tell you right now that if you're on, if you're looking at anything like Recorded Future, Cyber Daily, there's new attacks all the time that come on a daily basis. There's new attacks. And typically what a lot of the zero-day attacks that come out is the fact that somebody said, wow, man, check it out. I found a new weakness in Windows 98, or I got a new weakness in Windows 7, or whatever. So what I can do, if I found a new weakness in an older version of firmware, I can take and I can downgrade your firmware. I can implement that actual attack, right? With our firmware starting at 6.5, we implemented, we have a closed OS that runs on a signed firmware signature. That means before I put out a device, I take a physical digital signature of the hardware. When I create the firmware, I have to have a matching digital signature for the firmware to go on it. All my techs out here know that we have a bunch of different CPPs, right? CPP 4, CPP 5, CPP 6. And you can't put a different firmware on to a different platform. That's because of the digital signature. With 6.5 and above, we have two-factor authentication. That means firmware 6.5 has a decryption mechanism, and everything above that is encrypted. So you cannot load any firmware onto a device unless it is encrypted. Now that means you can't downgrade from an encrypted version to a previously unencrypted version. You're stuck like Chuck, okay? Now, with that being said, that prevents downgrade attacks. Does that kind of make sense? Because there are a couple of vendors out there that I can downgrade like it's cool. I can implement older attack vectors, and then re-upgrade it, and it never even shows that I changed something in the background, okay? Now, we got a thing in our devices called a crypto coprocessor. Now, I love the people in marketing, but the problem with the people in marketing, they always say, we got a TPM module. We do not have a TPM module. We have a crypto coprocessor. And a crypto coprocessor is sort of like that T100 chip, right? You can't break it. That's what holds the keys when we start dealing with certificates and PKI, public key infrastructure. That's what holds the keys inside the device so that nobody can get them and that your certificates are secure, okay? So one of the things we do in my cybersecurity class, we work with certificates. I show you how to create a root certificate, how to do signing requests, the whole 9 yards. Because right now, certificate TLS 1.2 encrypted communications is key for anything that you're doing, okay? Now, a couple of things that I'm going to talk about real quick, and this is really important because in the next session, we're going to do a little bit of brute forcing. I got a little simple little program I wrote in Python, and it's an FTP password attack vector tool. It's pretty simple. I'm not a programmer, but I wrote it, so it's kind of scary to think of what somebody really smart can do. One of the things that we've done, and I've kind of done a timeline with this, since 2017, we've had a mandatory complex password in the actual devices. That means you have to have at least 8 characters, upper, lowercase, special character, alphanumeric. Now, I kind of passed math for Marines, okay? So what I'm going to do is, we're going to talk about the next little section here. If I've got a upper, lowercase, special character, I got to start thinking, how many possibilities can I have to have a password for that? Well, here's the deal. If I got, how many letters are in the alphabet? 26. Okay, so I got 8 to the 26, that's uppercase. 8 to the 26, that's lowercase, that's 8 to the 52nd. Then I got about 10 special characters I can do, that's 8 to the 62nd. And then I can do 0 through 9, that's another 10. I've lost track. That 74 to the 8 to the 74th, right? How many IP addresses are in a B class address? 65,000 and some change, right? So if you're on a B class address, one of the things that we have that nobody seems to know about is inside all of my devices since 2015, we have a built-in login firewall, which means if you have 3 failed attempts to log into a device within 20 seconds, the IP camera keeps a black list and a white list. And if you bail 3 times in 20 seconds, it puts you on a blacklist. Now, since I'm at 8 to the 74th or whatever you just said, is that more than 65,000 attempts? Yeah, and I'm pretty sure you're going to run out of IP addresses before you can brute force into the camera, because every time you get blacklisted, you would have to change the host IP address. Make sense? Okay, so what we're going to do, we're going to talk about how easy it is to lock a device down. I got to put my readers on for this. Hold on a second. So what we're going to do is I'm going to come over to here and I'm going to open this puppy up, and I got a camera. And you're going to say, well, Dave, you got one camera. So one of the things we do in our cyber class is we teach you how to lock a camera down. And in the class, everybody's got one camera, and they're like, well, I'm only doing this to one camera. What if I got 50 cameras? The cool thing about Configuration Manager is you can take and you can select all 50 cameras and do this in one fell swoop. So I can literally lock a camera system down, or chunks of it, in just a few seconds. Now, there's a couple of things we're going to talk about real quick. By default, and I get this all the time, by default, Dave, your camera's on TLS 1.0. Why is that? Well, guess what? There's actually people out there who still have Windows 7 machines in their stinking network. Don't ask me why, but they do. And guess what you can't do by default on a Windows 7 machine? TLS 1.2, unless you do a registry hack and you do the last Windows upgrade, okay? Now, with that being said, in a minute we're going to talk about TLS 1.3 and 4K certificates, which are coming. And I will give you a very brief warning of what you need to have in your brain housing group before you start doing that, okay? So the catch on this is, let's say I got 10 cameras out there, 50 cameras I can take, and I can say, you know, I'm going to highlight this. I hit shift, I hit everything. The first thing I'm going to do, and this is going to be really quick, I'm going to turn off THC, or we'll come down, I'm going to turn off my browser port on 80. Because the whole purpose of locking a camera down is to reduce your attack surface, right? If anybody was in the military, there was a ditty. It's, I'm up, they see me, I'm down. That's a 3-second rush. And in the Corps, we used to say, I'm up, they see me, I'm hit. But that's beside the point. But you want to reduce your attack surface, because if I can't see you, I can't attack you, correct? Now, if I turn on my HTTP browser port, I just killed port 80. I'm going to bump this to TLS 1.2, and there's this little thing here called HSTS, and it's probably one of the most unknown little features out there that people just don't get. Does anybody know what HSTS is without looking at your Google machines? Who saw Wrath of Khan? Star Trek Wrath of Khan. Everybody remembers Lieutenant Savick, correct? Enterprise is rolling up on the Reliant, and Kurt can't communicate. He goes, drop your shields. And what's Lieutenant Savick say? You can't do that. That's kind of stupid, right? It's against Starfleet regulations. But what's he do? He drops them. So when you're dealing with an encryption downgrade attack, what HSTS does is it keeps you from dropping your shields. So if I put all my cameras on TLS 1.2, which means it's non-cracked encryption at this point, and then I'm an attacker and I come up to you and I say, you know, I'd really like to talk to you, but I'm just a poor Windows 7 machine. I can only speak TLS 1.0. Will you lower your encryption standards? Well, Captain Kurt would do it, but with HSTS, my little Lieutenant Savick, they're going to say, don't drop the shields. That prevents encryption downgrade attacks, okay? So if I come into here and I got this all nice and set, I literally only had to do a couple of things. We can do UDP encryption as well. The next thing I'm going to do is if I go to my actual network services. Now, I don't know how many of you guys actually work with different vendors' cameras, but the ones that I have in my lab are very difficult to work with. Like, you got to go into here and you got to do this, you got to do this. It's, I'm not going to say that. But the cool thing about these cameras are we provide you a scoring system and a lockdown page. So I can literally come in here and say, you know what, I'm not doing anything with Genetec, so I don't need RTSP on, I don't need RTPS, I don't need OnVIF Discovery on, and I don't even want my cameras to respond to an ICMP request or a ping. So that means I've just shut down all ports that I don't want. I'm not going to respond to a ping request. So if I'm scanning your network, because that's one of the phases of an attack, is to find you, and I turn the ICMP response off, camera doesn't play, all right? It's not asking facility for one ping and one ping only. With that being said, I literally just took, and I've got the camera to where if I do an Nmap or a Nessus scan, which we do in my cybersecurity class, you're going to get hardly any return at all. That means you have a nice low attack surface. And it's literally just a couple of clicks, all right? So what I got to do real quick is I have to switch back to this. Give me 2 seconds. All right, so we just talked about that. We want to talk about certificates real quick because I think this is a really huge feature that most people don't understand. And this also plays into basic vulnerability scanning. All of our cameras, when they come out of the factory, inside that crypto coprocessor, have 4 basic certificates, okay? We've got an HTTPS certificate. That means it is a default certificate that when you try to do communications and you want to pull video that's encrypted, TLS 1.2, yada, 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 it is a root certificate, and I will send you a dynamic public key for you to decrypt that video when it's coming to you. That means when you're in BVMS or VSC or whatever you're using and you're doing encrypted video, you're getting a dynamic public key so that you can decrypt the video into your video camera or Cameo. Make sense? Now, the next thing that we have is we have what is called a LUT encryption key. When you're doing the cyber class or an advanced BVMS class, I teach the master class as well, we have a feature called VRM encryption, all right? Now that means that we're going to encrypt our already proprietary iSCSI video on the actual iSCSI target, as well as it just being proprietary and not being able to be read by open eyes, okay? So inside this, we give you an AES XTS encryption key. That means when you start doing any kind of encryption, either on a micro SD card and or in a VRM scenario, you're encrypting it with two types of keys. You're encrypting it with the VRM's public key, and you're encrypting it with the camera's symmetric AES XTS encryption key. So we go over that in depth in our actual class. What's really important though, and most people don't know this, is that way down here, I have got this little thing called a basic internal usage encryption key. And what that will do is you have an actual system encryption key, and everything that you put into the camera is encrypted. So if you have to take a camera off the wall and send it back, what you can do is you can delete that actual encryption key, and it will blow the camera back to prior to factory defaults, because everything that you programmed in the camera is actually encrypted with that key. So after factory defaulting, if you blow that out, it takes anything that ever happened away. It's sort of like these aren't the droids you're looking for. Kind of makes sense? And last but not least, there's an eScript certificate in here. And what the eScript certificate is anybody familiar with the eScript certificate company? So eScript was doing certificate injection to Bosch automotive parts since about 1997 because there seems to be a very large black market counterfeit auto parts market out there. And of course, you probably drive a Jag or something like that. And if you want your car fixed, you want it fixed with authentic Bosch parts, right? So we will inject certificates into the auto parts so that when it puts it in your car, they're like, oh, this is a real Bosch auto part. You paid top dollar for it. You can't get junk. They did such a good job that we bought them. And now every camera that we put out gets an eScript certificate injected into it at the factory, so that when you plug it up in Configuration Manager or BVMS or VSC, you know that you're not getting a cheap knockoff. You're getting an authentic Bosch camera that hasn't been touched since it came off the assembly line. Make sense? All right. So, yes, sir.
If there is a knockoff,
Can you hit the button and speak?
if there is a knockoff one, what would the system say to show you it's not real?
Well, one, more than likely, if it was a knockoff one, it wouldn't be speaking RCP Plus protocol the correct way, so it really wouldn't come up as a Bosch camera. And then if you went to actually examine it and it didn't have that certificate in it, you knew that you got a piece of crap. So when you're in Configuration Manager, you got to remember we're using a proprietary protocol to communicate to our cameras that we developed, Remote Control Protocol Plus. So if they did a knockoff, and they're good at doing knockoffs, they would really have to have it down tight. Kind of makes sense? Okay. Yes, sir.
Excuse me, sir.
Yes, sir.
Can you change the encryption key if you need to?
Okay, so the question was, can you change the encryption key? Are we talking about for live video?
Correct. Within the camera, how you
Okay, so one of the things you can do...
key, and then it will turn back to factory, but you can update the old key.
Yes, you can. And so what I'm going to do real quick, and I'm going to do this just for you because I have a few minutes left. So one of the things that we've done since we're into security is, since you're into certificates, you know what OpenSSL is, correct? So what we've done in Configuration Manager is we put in a micro CA, which is a micro certificate authority. And one of the things that you can do with the micro certificate authority, I'm going to do this really quick. All right, and we do this, you can ask these guys, I make them do it in class. It's terrible. It's like exercise. So I'm going to come in here, I'm going to do a common name, I'm going to do Bosch 007. I probably didn't type that right. I didn't. Thank you very much. D. I'm going to make this 2048. I can make an elliptical curve, whatever. I'm going to create a root key. I'm going to trust this so it goes into my Microsoft certificate store. Now, one of the things that you can do with the devices, I'm going to hit yes. I'm going to come back to service and certificates. One of the things that you can do with the device is that, and I was getting ready to get to this, if you're in an 802.1x network, or you're in a Genetec cloud system, or whatever you're doing, and you need certificates for different things, say for user login, domain login, you can take and either use the internal certificates, or you could say, I would like to generate a signing request. And I'm just going to leave it with this. And since my root key is 2048, I'll go ahead and create it. And in a minute, it will create it. Now, if I'm doing say a 50 camera system, remember, I can do all 50 cameras at one time, say generate a signing request, and then the root certificate that I just generated, or a root certificate that you bring in, you can take and sign all 50 cameras. So you don't have to keep the default keys, but on every camera, every key that is generated uniquely. So you're not getting the same root HTTPS encryption key on every camera. It's generated uniquely based on the crypto coprocessor and an algorithm they're running internally. So does that answer your question?
Yes.
Okay. And we'll see if it actually did this real quick, and we'll see what happens. Because I only got a few minutes, and I got a lot of stuff to cover. So while this is sort of like a cooking show, isn't it? You have to just keep coming back. So I go back to certificates. Look, I got a signing request, and if I say I'd like to sign it, it got signed by my almost Bosch 007, and then I can apply it to any role that I have, okay? So going back to here really quickly, because I do want to hit this. One added note, with the new 7.8.1 firmware, we now also support certificates with SHA-384. So if you're pushing a higher SHA algorithm for your PKI certificates, for your root certificate, we now support a 384 algorithm. Another thing that we have real quick is we have software sealing, so that if you put software sealing on and someone actually makes a change to the camera, you could get notified that someone has made a change to the camera. But the one thing I love, and I was going to do this live, but I don't want to lock myself out of my camera, we have an IP4 filter. Now, if you understand subnets, what's going to happen is this does not affect your actual IP address of your device. My question is, if you've got a video system, how many devices actually need to talk to the camera? Central server, maybe? If I'm in a Genetec system, it's the archiver and the directory the server service, the directory. If I'm in a BVMS server, it's the VRM, it's the workstations, whatever. So if I've only got 10 or 15 people that actually need to talk to the camera, I can produce a little pseudo subnet that will only allow people within the subnet I designate to actually talk to the camera. So in this instance, I've put a pseudo subnet of 240 in, and then I've designated which one of the 16 subnets I created is actually going to be able to talk to the camera, and that's the .16 network. Kind of makes sense? Now, you all heard that we have a new Antiox camera, right? So the deal with the Antiox camera, I said we had all of our regular CPPs, we had CPP 13, which is Antiox, and then we have CPP 14 and beyond. So what Antiox does is it gives you the ability, because we've switched to a sandbox Android OS on this particular model, and it allows you to take third-party apps from the Azena platform and put them in the front of the camera. And you're like, why would I do that? Well, it depends. I've got one installation in Germany that they're not even looking at video. They're just taking the metadata. They've turned all the video off on the device, and all it's doing is recording metadata. You're going to love talking about metadata here in a little while. But the cool thing about this is, the apps are sandboxed. You can't touch the OS. It's still our stack that we typically have. And we upped the game. We went from a crypto coprocessor to a secure element. Now, what's that mean? Has everybody got one of these guys? Everybody got one of these guys? It's a phone. Go figure that one out. Hey, check it out. Guess what? Phones don't use TPMs. They use secure elements. So what a secure element does is it gives you TPM and crypto coprocessor functionality, and it can handle larger algorithms. So with the implementation of the secure element in the CPP 13 and CPP 14 and CPP 14.1 and everything we're doing from now on, we can now do TLS 1.3 and we can do 4K certificates because we have a better processing platform to handle certificates. And you're like, well, damn, I don't want to do anything with Android. Well, if you don't want to do anything with the Antiox cameras, CPP14 has still got that device in it. Now, the cool thing about this is we are already out of the box EAL certified 6+. If you're not familiar with EAL certification, it goes from 1 to 7. So out of the box, we're really secure, okay? Now, what this gives you is it gives you enhanced functionality, and according to the NSA, we're good till 2031. And as what Sachin said last night, he's like, oh, we're going to have 8K certificates. It's like, what are you talking about? He was making stuff up at dinner. Never mind. I said, just put a 15K certificate in there while you're doing it. Okay, so what I want to do real quick, why is it technically a more secure platform? All right, so what we put into the actual Antiox cameras was a Snapdragon chipset. And what the Snapdragon chipset affords you, it affords you a secure boot. So that Snapdragon chipset is actually what most manufacturers use in their phones, okay? That means it will detect it if there's any type of malware in the boot process, and it will not allow that stuff to actually run. Kind of make sense? CPP 14 and beyond, we're still going to be using the same secure elements, and we're going to a quad-core processor platform, which gives you more computing power for security and more computing power for video. We already got the best video in the industry, but we're up in the game. So now we're not only taking what we've done since 2004 from a secure platform process, we're now upping it way up. We're giving you better video, and we're giving you more security. Kind of makes sense? Okay, so end-to-end features. So I got a question real quick. So we only have a few minutes. Is there any questions on what we covered at this point? If you have any questions, now's the time. Okay, cool. So from an end-to-end process, I don't know who's you. Okay, yes, sir.
I do have one question.
Yes, sir.
So you have gone over the certificates, but I just want to, I think I have a misunderstanding. So the cameras do come with certificates and they have the
Yes.
Yes. But I have talked to other people and they said that if I wanted to get a TLS certificate, I would we typically use third-party certificates.
Okay.
So I was just kind of confused on that.
Okay, all right. So his question was, what's the deal with certificates? So let's do it this way. A certificate. And we do cover certificates in my cybersecurity class. So guess what? I expect to see. Okay. So here's the deal. What is a certificate? A certificate is something that associates an identity with an item, a server, whatever. So I right here have a Virginia driver's license. That is a certificate. And my certificate authority in this case is the Virginia DMV. They're the ones that validate and say, you know what, you're really Dave Brent. You're not Ricky Gervais. You're David Brent. Because if you Google me, guess what? You get 500 pages of Ricky Gervais. It's great. I love it. Nobody can find me. So here's the deal. Anybody can be a certificate authority. So if you got a camera and you want to use a third-party certificate authority, which means I've got this valid eScript or I've got VeriSign or whatever, you can do it. I can open up a Linux machine and I can say I want to be my own certificate authority. And I can create my own root certificate. So in the camera, I can either issue certificates and just load them into the cameras, or I can create a signing request. And I can sign that certificate with my root certificate authority, okay? So I do a whole entire, a half a day on certificates in the class. It is. It's good, and it's hands-on. And when you get done with it, because I break it down Barney style, I teach it exactly the way I would teach Marines to use a map to get out of the woods in the dark with a compass, which is scary. Honestly, it is. Does that answer your question?
Yeah, so I think I was in your certificate authority. So you guys have a certificate, but we need to provide a certificate.
But you can be your own certificate authority because we have a micro certificate authority in Configuration Manager. So that's kind of what I did on the backside. If you don't want to go out and get a third-party cert or mess with a Windows domain controller or open up XCA or open up a Linux machine and do OpenSSL, you can do it just with Configuration Manager. And you don't have to mess with extra servers and all that goobly-goo. Make sense?
Yep.
Okay. How much time do I have?
At least predict that.
All right. And don't go with the joke we told last night.
I need to take your class first of all, but is this just something I remember? So I'm not sure if I remembered right or something's changed, but I recall something about if you put a certificate on the camera and the certificate expires, you break the camera.
You've what, the camera?
Break it.
You don't. No.
Get out of it. Is that
No. So his question was, if I put a certificate and it expires, does it brick? I got 5 minutes. Okay.
If you downgrade the firmware, you break it.
No. That's. My gosh, who have you been talking to? People that haven't taken my class. And all right. So last couple of things real quick. I just want to make sure that we're square on. Starting with BVMS 10.0, because here's the thing. You can have cameras secure all day long, and if your actual VMS is a piece of crap and not secure, you're toast, right? So starting actually a little bit prior to this, but fundamentally based on BVMS 10, everything that you do in a system is automatically communication via TLS. That means when you add the VRM in, it's TLS. We're not doing RCP plus right out of the gate. You add a workstation, it's TLS. You talk to the cameras, it's TLS. You talk to a decoder, it's TLS. So what we're offering you now is the fact that you're getting end-to-end communications between all the parts and pieces, and you're doing it via encrypted communications, okay? The next thing is, like I said earlier, we now, if you haven't read any of the white papers I wrote on our recording format, when I was doing my bachelor's degree in computer forensics, I had written a paper for Steve for a few agencies on how we record. And when we record in iSCSI format, it's a proprietary format. We're not doing MOV files and we're not doing MKV files or anything like that. We're recording in a proprietary .dat format. You cannot see the video on a hard disk. But some people were like, well, that's security through obscurity. So we said, okay, great. So we are now doing VRM encrypted video, which means the VRM has a set of PKI keys. That's public infrastructure or key infrastructure. And like I said earlier, the camera has a symmetric AES XTS encryption key. So we'll use the typical key communication / handoff through a 2-key encryption process, which everybody pretty much uses. The last thing I want to talk about is how much have you guys heard about the way we do stuff in the cloud? Anything? Going once, going twice. So I just got done, I would say just got done. In January, I put together a remote portal technicians cloud class. And one of the questions that comes up all the time, you guys are doing stuff in the cloud. What about that Verkada hack? You know, they got hacked and they're in the cloud. When you do stuff in our cloud, and this is really great from a technician standpoint, I know it doesn't apply to half the people in here because it's government. We got 1 minute.
I want to interject that the last session today is all about your topic. Right?
Okay, cool. When you do stuff in our cloud, it is in an AWS, and as soon as you make a remote portal account, you get assigned a virtual private cloud. Now, with that being said, inside the cameras, the only thing talking to that cloud is the camera, because inside the camera, there's also this nice little hidden key, and that is the cloud's public key. Because the cloud has a root private key, and when you introduce this to the cloud, it talks via HTTPS, TLS encryption, and it ain't getting into your cloud or your account unless it has the correct key. Make sense? So I want to make sure that, you know, it's like, well, Dave talked about cameras, but he didn't talk about this. There's too much to talk about in a 45-minute session. And the next session, I'm going to try to make your head explode, actually. So before we part ways for 5 minutes and then come back and actually get into the meat and potatoes of what's really going out there out there in the crazy world that we live in, are there any questions? He's got one question.
How are you implementing the 256 encryption? The AES 256 bit?
Okay,
How
so
is it being uploaded and implemented? Because I know working with Statcom that I had to get separate keys and
okay, so when we're talking about 256-bit encryption and we're talking about, so which data state are you talking about? Are you talking at rest, in use, or in motion?
in use.
In use. So in use means that I'm actually doing playback. Or are we talking motion from camera to...
Well, I'm just talking about your encryption in general, your AES 256.
Okay, so if I'm doing at rest, because data lives in 3 states. It lives at rest, that's recorded. In use, that means I'm pulling it back, I'm exporting, I'm doing this. Or in motion, that's point A to point B, okay? If I'm doing it data at rest, the XTS AES encryption key that is in the crypto coprocessor in the camera is handling on a span-by-span basis how it encrypts video at rest. If you are going to connect to me and I'm doing TLS 1.2 HTTPS encryption so that you're getting encrypted video from the camera live, when you make the request, if we're doing HTTPS video, not UDP, we're doing TCP, I will stream to you a dynamic public key. Now, it's sort of like when you go to the bank. If I went to Navy Fed and he went to Navy Fed, he's going to get a different private or public key than I do, right? So if you connect and he connects, I'm going to send each of you a different dynamic public key for you to decrypt that actual video. Now, if I'm talking about data in use, which means I've got the video played back in BVMS and I'm doing VRM encryption, the VRM has the private key. When you start encrypting the video, what happens, and I don't want to get too in-depth because we're running out of time, the camera will encrypt the block with its static AES XTS encryption key. It will then encrypt the key that it uses, a dynamic key, on top of the block with VRM's public key. And then if you want to see that video, in class I do this with gummy bears, that's why I've sort of put on a little weight. I will take and I will decrypt the static AES XTS encryption key off the block and then play the video back to the client through the VRM. Does that answer your question?
Yeah, that makes sense.
Hoorah.